Okay, anyway. All right, so guys, we're starting with Unit 10. Here's some things you need to know about Unit 10. You have to know all of Unit 9. All right, so all the area formulas that you have memorized are still going to be applied almost every single day in this unit. So you have to know all of those. So take a quick time. It's been a good week since you've seen that over spring break. I'm sure some of you lost a few of those formulas. Make sure you know those. We are working with what's called solids. Now, solids does not mean someone like when you describe someone like, man, he's solid. Does not mean we're talking about being something being strong per se. We're talking about three-dimensional shapes. So, like when you're looking at that, when you guys see this block in my hand, what do you guys see? A cube, okay? So a cube is a solid. What's the shape?
Cylinder.
A cylinder, okay? It's three-dimensional now. We're not just talking about two-dimensional things. We're in three-dimensional words. So like if you were actually working with a coordinate plane, you have an X and Y axis, and then you'd have a Z axis coming out at you. That's calculus. We're not going to go there at the moment, but you can easily do midpoint, distance formula, all with those. In fact, we're only covering a little bit of lesson 10.3 that's in your book. Go in there and just play a little bit. You're going to see how they do midpoint, three-dimensional, and all that type of stuff. It's really kind of cool stuff. But all different shapes that are three-dimensional is what we're working with. So we're doing solids, and that's just the way we describe it, 3D shapes or solids. So this chapter is all going that way. A lot of terminology I'm going to expect you to know. A lot of definitions. So today is a lot of definitions and kind of filling in a little bit of gaps that you need to have to be prepared. Are you guys ready to go? All right. So with this first one here, we're talking about three-dimensional shapes or solids or flat or curved surfaces, so no big deal. But each flat surface has a special name that's called a face. All right. So a flat surface on a solid is called a face. We also have what's called an edge, and the edges are pretty easy to kind of get the idea of it. An edge is the segment that's the intersection of two faces. Guys, think about a flat surface. Isn't that a plane? Okay, so when two planes intersect, what do they intersect at? A line, right? So when I have two faces intersecting, is that going to be a line segment? Does that have a naturally kind of flow from when we're working at it? Looking at that diagram right there, how many edges do you see? Any two faces intersecting, you should have 4 on top, right? So you have 1, 2, 3, 4. Then the edges that are all vertical, and then you have the 4 on the bottom. So you should have 12. So in that one, this simple rectangular prism would end up having 12 edges. All right. Also, we still have a vertex. A vertex is a point that is the intersection of 3 or more faces. So when you have 3 or more planes intersecting, we'd intersect at a vertex. Honestly, isn't that a vertex also when we have 2 line segments intersect, right? And they have a common endpoint. So really, when I'm looking at that, don't you guys see? I'm going to look at the red vertex because obviously there, in this case, we're going to have 8 vertices for this shape. But do you guys agree with me? I'd have an angle right here I'd have to worry about. Do I have an angle right here for this one? Or how about the angle right here? The one on the bottom. If I was doing this, wait, let's make it so it looks like it's 3D. On the bottom, dashed, right? So you're not supposed to be able to see it. So you're going to actually, that vertex right there has 3 different angles. It could have more than that. So again, when you name an angle, be very careful when you're doing those. Make sense? All right. Now again, hopefully this is review, but we're going to talk very carefully about this. The first one is called a prism. Did any of you ever, in somewhere in your schooling, okay, and mostly it'd be like elementary science class or something, ever play with what's called a glass prism that bends light so you see the rainbow going through it? Because I about dropped my prism on my surface. That would have been bad. All right, so the idea would look something like this, but it'd be either clear plastic or clear glass. Okay, that's an easy way to remember what you're looking at. That's called a prism. Well, what are the sides of a prism? Well, don't those look like rectangles? So, aka parallelograms. Right? So I'm going to have the sides are going to be parallelograms. Also, we had 2 sides that are going to be parallel to itself. Those have special names. So let's go ahead and work with that. What is a prism? Well, first of all, it is a figure, okay? You can even say a 3-dimensional figure if you want. Formed by 2, what are we going to have here? Parallel and congruent polygonal faces. Called, now okay, those polygonal faces, those congruent and polygon, those are actually called bases. So we're going to talk about a base. Now, here's the thing. A base does not have to be on the top and the bottom. A base can be about anywhere, okay? But the bases have to be congruent and parallel to each other. So like in this diagram that you see here that's shaded in red or orange or pink, it looks like pink for you guys, pink, those are triangular bases. They're congruent to each other and they will never intersect. So they have to be parallel, congruent, and the same. Make sense? And also the faces that connect the two bases, and this shouldn't say area, it should say what? Are, that are parallelograms. So I'm going to have parallelograms to be the other sides. So the sides that aren't called bases, by the way, we're going to talk about this tomorrow, they're called lateral faces, but don't need to worry about that until tomorrow. All right, our next one, and by the way, I did not put enough blanks on this next one, so you're going to have to kind of, don't write too big. It says the following is a cylinder, and a lot of you know what a cylinder is because I am pretty positive, unless you have a very deprived childhood, that you probably played either with a paper towel roll or a toilet paper roll or a wrapping paper roll at least once in your life, correct? All right, so you've all played with cylinders before. My favorite cylinder is this Slinky. Let's go there. All right, so you've all worked with those. So when I say a cylinder, this shouldn't be an earth-shattering thing. You just didn't probably ever had a formal definition for it before. So let's write this down. So with this, a cylinder is formed by two parallel, congruent, circular bases. And I almost got this fit. I'm gonna have to go back. Sorry guys, I just want to fit. It's a beam just particular. Circular bases. And a curved surface that connects the bases. Now, when you talk about a cylinder, there's only two things that would be called faces, and that's the two bases, right? The two circles. The other one can't be considered, the rest of it that we know to be a cylinder, the curved part, can't be considered a face. They literally don't have a better description, so they called it the curved surface, okay? But, because we can't call it a side, right? But in our brain, it's the sides of a cylinder, right? So kind of think of it like that, but just be careful of the definitions that you're using with it. All right, next one, a pyramid. And when I say pyramid, how many of you instantly just went to Egypt on me? Didn't you? I know you guys well enough to know because that's where I go, all right? Or and if anyone's gone to Peru, they'd be like in Peru, they have their pyramids as well there. But when you look at a pyramid, what's so special about it? Its sides are what? Yeah, the sides are triangles. Yeah, and then you have some bottom for it, correct? And a lot of what we think of the pyramids is like the one I have right here. The bottom is normally like a square or something like a quadrilateral of some sort, right? And it's very easy to see the triangular sides that make that. But here's the thing. It doesn't have to be a square. It can be any polygon for the base. So any polygon. You could have a trapezoid. You could have, you know, a funky looking parallelogram or, you know, anything like that. A rhombus, a kite. Anything that's a polygon can be the base of a pyramid. But you're only ever going to have one base, all right? So a few things we need to know. A pyramid is a figure formed by a polygonal base, just long as it's a polygon, and triangular faces that meet at a common vertex. Now, how do I know if something's the base or not? Here's how you know if something's the base of a pyramid. It's the one that doesn't go to the vertex point. None of its sides can touch that vertex point. All the other figures are going to end up going and intersecting there. The base will never do that. So in this diagram, that base is actually a triangle. So that'd be called a triangular pyramid. It wasn't a square like what we're used to. So understand, don't put yourself like in those cookie cutter shapes that you learned as a kid. Put the other ones in there. All right, next one on here, and I hope you're not hungry. We're going to talk about a cone. Because the moment I say cone, where did y'all go to? Yes, okay. Come back, okay? So we have a cone. Is a figure formed by just what? A circular base, right? And a curved surface that connects the base to a vertex. So the point of a cone literally becomes now a vertex. So Oh, when we talked about vertex before, it always had to be formed with line segments, right? Notice now we have a vertex of a cone. But think about it, could I draw line segments that would intersect there? So could I get away with calling it a vertex? Yeah, so be very careful with it. We have our vertex point. And a base of a cone is probably the easiest one that can work with it. It's just the circle that we're working. So cylinders and cones are like my two favorite because they're the two easiest to work with. All right, so those definitions, do you think it'd be important for you to know those? Yep. Don't be afraid of surprised if I asked you something that would require you to know these on your quiz next week, okay? So keep on top of that. All right, another definition that you need to know, and it's called a polyhedron. All right, a polyhedron is a figure, so a solid, that is formed by 4 or more polygons, okay? So it can only have polygons, it can have no curved surfaces. So it really makes sense. Polyhedron, right? Polygons. Thank you so much, ma'am. All right, now here's a few things you need to know. You're going to be good at working with polyhedrons and non-polyhedrons. So this is just a quick examples of the ones that would count, which ones don't count. Anyone have ever heard of like a dodecahedron before?
Oh, yeah.
All right, it just has how many sides? 12 sides. So there you go. Dodecahedron. So making sure you know those. Do you need a pass? Okay. All right, now easy schmeezy, just make sure you know what understand the terminology of polyhedron. But then the next one is, and this is where I totally was poor at doing this, Euler's formula. Notice it's not Euler's. Doesn't that look like Euler to you? Yeah. Euler. Okay, almost like Euler. But anyway, Euler, it's actually Euler, okay? He actually is pretty famous mathematician. This is one of his more simple type of equations that he has. But this actually, you can solve for the vertices, edges, and faces of any polyhedron using this formula. Now, different books will rewrite the formula differently than this, so pretty simple. But the idea is that if you know 2 of the things, you can always solve for the third. And it always works for any polyhedron. Isn't that kind of cool? Any polyhedron. So the formula that you use is V minus E plus F equals 2 is Euler's formula is really what it is. Memorize it, know it. I do expect you to know it. I'm going to show you some quick, easy examples of some of the easiest algebra you've done all year in order to solve for the missing parts. But you could do this for any pyramid, any prism. It'd work every single time. And it will always work. Otherwise, it's not a polyhedron. If it doesn't work in this formula, it wouldn't be a polyhedron to start with. Kind of cool. All right. Also, another thing, if you guys didn't know this by now, I'm greatly concerned. A cube is a prism with 6 square faces. I really am concerned if you didn't know that. And they're all the same size and shape, correct? So make sure you know those. And this says don't write down. Guess what I want you to do? I want you to write down. So just ignore that. I changed my notes from past notes. It says other prisms and pyramids are named for the shape of their bases. So here's the thing. You can't just look at something and say, oh, look, that's a prism. Great. You have to be more specific. You need to tell me what type of prism that they're working with. All right? So, for instance, look at this right here. Owen, look at that for me. What's the base? What shape is it? How many sides is it? Yeah, it's a hexagon. So, guess what you would call that prism? Yeah, hexagonal prism. All right, let's put it in here real quick. It's just as simple as you guys see right here. So it's a hexagonal prism. Simple as that. The moment you know it's a hexagon, did anyone sit there and go, oh, great, apothem times perimeter over 2? Yes, you should be thinking that right now. But also, this is a prism as well. What's the shape for this? Triangle. Be more specific. What type? Could I say an equilateral triangular prism? Yes, you could. Okay, you say name it by its base before you say it. So like on this first one, it's not equilateral. It's not an equilateral triangle. It's just a triangle, right? Remember, they have to be congruent and parallel to each other. So that's what you'd call that prism, a triangular prism. So you shouldn't go around and go, oh look, a lot of prisms. Be more specific. Okay. The next one, what would you call that one? What's the problem with rectangular prisms is the fact which sides are actually your bases, because you have all of these, you have like 3 pairs, right, of parallel sides. And my answer is yes. Yeah, right. It's just, I normally say pick top and bottom to be your bases, but a lot of times you look at them like, what's the easiest help on my problem? Like which one would I use as my base or not? So rectangular prisms, not as much as nice. But the other ones is very helpful. Guys, what would you call that last one that's not filling in that first line? Yeah, pentagonal. And you use the same idea when you're talking about pyramids. So like on the first one here, that would be a triangular pyramid. And the next one would be what type? Yeah, rectangular pyramid. And then so on. You look at what the base is and its shape. And it doesn't have to be regular. It doesn't have to be exciting figures. It just has to be a polygon. So this would be like a pentagonal. Octagons are normally used a lot. So we have pentagonal pyramid, hexagonal pyramid, all of those. You have to know to find the area of all those types of bases. Remember we used trig for the one that was a pentagon. You've got to know those. All right, let's have some fun with this. All right, in order not to bore your life on homework, I'm boring it in the notes, okay? We're going to identify vertices, edges, bases now. You don't have to do it later. Are you guys with me on that? I think you'd be okay with it if we do it here and not on the note homework. All right, so in this one, you're supposed to classify the figure. Then you're supposed to name the vertices, edges, and bases. So basically, we're just identifying the different parts of your prisms and pyramids and shapes. All right, so in the first one, what would you classify A as? Some of you said cube, and someone else said what? Yeah, right now it's like, am I certain on either one of those? I would probably say, to play it safe, I'd probably say a rectangular prism. But if you would have told me a cube, would I have given you full credit probably on this one? Yeah, because I just didn't give a lot of information either way. We know for sure it's a prism. So we know a cube or a prism on this would work. But with it, you have to name stuff carefully. So we have our vertices. Well, vertices are all points, so this makes it really easy. I just got to name all 8 vertices. So go PTS, because remember, we got to use correct notation. Hey guys, a few things I noticed on some last homeworks and stuff. Don't forget notation on things. When you're naming a line segment or angle, if you're naming an angle measure, you put an M in front of it, right? Length of a line segment, take the bar off. All that stuff is still going to come in handy when you're talking about these. So for the points, just list them real quick. A, B, C, D, E, F, G, and H. So that's our vertices. And then we're going to name edges. Guys, how many edges am I going to have to name?
12.
Yeah, it's going to be 12. The ones, basically, remember when the two surfaces come together, or two faces come together. So all those line segments, every single line segment there is an edge. Now, that we get more specific later, we talk about base edges and lateral edges, but we don't need to worry about that now. But I need to name every segment. So I always name the horizontal ones first, and then I try to do the vertical ones on here. So I got here, you just go around the top, segment AB, segment BC, segment CD, and segment AD. And then I'm going to do the bottom rectangle as well. So got segment EF, segment FG, segment GH, and segment EH. So we got four more left, right? We got to do the vertical and just go around the cube, rectangular prism, whatever you want to call it, and name those as well. So we got segment AE, got segment BF, segment CG, and we also have segment DH. Now, the only thing left is we got to name our what? Our bases on this. Let me zoom in here a little bit, guys, so you can see those a little bit easier. All right, our bases, in this case, I don't know really which of the sides are bases, so really pick a pair. And when you don't know, when it's a rectangular prism, just pick the top and bottom sides. I think are the easiest way to do this. So I would just sit there and go, oh, that's rectangle. If it's a square, if we said it was a cube, you could say a square. I'd be okay with that. So rectangle AB, I'm just going to go A, B, C, D. And I'm going to go rectangle E, F, G, H. So we named it. You also played it safe and said quadrilateral A, B, C, D. Right? Or quadrilateral E, F, G, H. Very simple. See why I'm not making this on homework? Yeah. What? On the notes, you don't have to do this on homework. That's why we're doing it here instead. So basically, I could have assigned this, and I'm like, nah. If they do it with me here, it's good enough, right? Okay, good. All right, next one. Guys, what would you call this one for B? Yeah, pentagonal or pentagonal. Awesome. So, because we know the base has 5 sides, so it's a pentagonal, all right? Pyramid. Now, with this one, you still need to name all the edges. So name the edges of your base, I think is easiest to do first. Just name those. So, actually, let's do vertices first. Sorry. Let's go vertices. We have our points, and this one we should end up just having 6 of them that we need to worry about. So we have A, B, C, D, E, and F. And then you should have your edges. And I would do the edges of the base. By the way, here's just a heads up for what you're going to be working with like tomorrow and other ones. If I'm using the edges that are on the base, guess what they're called? Base edges. Aren't you so excited? Profound moment in math class right there. All right. So with that, let's go through. Let's go segment AB, segment BC, segment CD, segment DE, and segment AE. So that's the edges all the way around our base. And then we got to do the ones that intersect at the vertex of the pyramid. So those just easily go around. You just go segment AF, segment BF, segment CF, segment DF, and segment EF. So going through with the edges on this one. All right, last but not least, you got to name the base or bases. How many bases does a pyramid have? 1, right? So you just have to name it. So our base, and be specific, it's just going to be pentagon, A, B, C, D, E. Make sense? All right, now let's look at the next one. When you have it, make sure I think everyone's about caught up with me. Guys, what are you going to classify the next figure? Don't be hungry. Cone. Yeah, that's a cone. I know. It's like, yeah, it's a cone. Here's the thing. Do I have any vertices? Yeah, you have one. You have the vertex, right? So the vertex is just point what? Point N. So the vertex of the cone is point N. Again, we could draw in if we needed to line segments that show they would intersect at that point. But it's just a key descriptor that we use for cones. Do I have any edges? Do I have any line segments? No, so I have no edges on this, so I don't have edges I can name. Now the base, I can't really name it well, but can I just say the base is a what? It's just a circle. But I don't have a way of identifying it because do I have the center of the base? No, it's not there, so I can't name it by that. We just know the circle is the base. All right, cones are nice. We like those. So much easier to work with. All right, D, what would you describe D for me as? This weird, funky little shape. Yeah, because our 2 bases have to be parallel to each other. And remember the way they show you that you're not supposed to be able to see it? You put dashed lines through it, so that way it's supposed to be like you can't see it, but it's there. So this would be a triangular prism. What are your vertices, my friends? Should be points what? Make sure you label it so it's points. Commas are good here. T, U, V, W, X, and Y would be my points that I'd use for that. You also have to name edges. How many edges should I have? How many edges did you guys get? 9, right. You should have the 3 base edges on top, the 3 on bottom, and then the vertical ones going on there. So there would be 9. So you have segment TU, segment TV, segment UV, segment WY, segment YX, and segment WX. And then the vertical ones, segment WT, segment VY, and segment XU. So you have the 9 different edges on there. And what are your bases this time? Does notation matter when I name them base? Yeah, you're going to have triangle. You just say TUV, and we have to have our triangle WXY. Because remember, they're polygonal. They have to be polygons, so we're going to name it as specific as we can. All right, makes sense? Now again, we did this here, so you don't have to do it on your homework. Fair? All right, next one, Euler's formula. So we're going to use Euler's formula. Guys, can I just have you all pause for a moment and look at me in the face, just for a moment? People get this wrong for two reasons. They don't memorize the formula, and then number two, their algebra skills went out the window for some reason, okay? You might laugh, but here's what I need you to remember. When you're solving for basic equations, always combine like terms first before you start moving things. When people don't, they get things wrong and they panic. It's amazing how they like flip out. Stop. Just do it the way that you're taught by your algebra teachers. Combine like terms first, and then you're going to get these pretty quickly. So what's the first thing you should always do anytime you have a formula? Write it down. So this one, okay guys, a quirky way of memorizing this, okay? And I use my name. You know how you can come up weird sayings and you'll memorize it better? So I was trying to figure out how to make this memorized. So this is what I came up for my saying. Valerie does not enjoy flowers too. Now, the doesn't enjoy is what symbol? The negative. So it's the negative E. And then flowers are always positive, so that's why it's plus F. Okay. But now here's the thing. That is so not true. I love flowers. But anyway, it's an easy way of doing it. Valerie does not enjoy flowers too. Change it to Vicky if you don't like my first name. Okay. So, but do anything like that that will help you memorize the formula, because a lot of people will like get an A on the quiz and they'll turn on getting a B or a C because they didn't do these well, because they didn't know a formula. Don't be that person, okay? You guys with me on that? So the quiz next week, don't be that person. All right, so then you just plug in what you do have. So here I got vertices are 5. Don't know the edges. Faces are 5 equal to 2. Guys, what's 5 plus 5? So really, you should be rewriting this to look exactly in that manner. You should not be going through. The reason why I put the 10 in front is so people don't drop the negative. And then you just subtract it over, and you should get the fact that is a negative 8, so E is equal to what? 8 edges. Now, this has to work or you won't have a polyhedron. You won't have a prism. You won't have a pyramid, those type of shapes. This has to be true or it won't be one of those. All right, so again, we're now looking for missing faces. So we got vertice minus edges plus faces equals 2. Plug and chug what you know. So I got 6 minus 9 plus F is equal to 2. Now, this is so funny because people are working with polyhedron. Right now, if I combine like terms, you guys agree with me, I get a negative 3. I don't know how many advanced geometry students I've taught in the last 20 years that will drop that negative that moment and then get it wrong and they go, I got a negative answer, something's wrong. And I'm like, oy, it's just bad algebra, okay? So with that one, just be careful. Moving it over, you should get the fact that it should have 5 faces. And then last but not least, first hour I wasn't paying attention and I wrote my formula wrong. So we got vertice minus edges plus faces equals 2. Plugging it in, I'm looking for the vertices. Combine like terms. Do not subtract the 8, then add the 18. Again, people mess this up a lot. I don't know why. Just combine them first and get the fact vertices minus 10 is equal to 2. What is your vertices going to be, guys? 12. Look at all those edges. Woo. 12, 18 edges with 12 vertices. Guys, what do you think? Euler's formula is so easy, isn't it? You cannot have a polyhedron unless that works. It's kind of a cool thing. All right, next thing that we're talking about is something that you guys, it's a big trend in math education, but it's really the idea of 2 dimensions into 3, is to do what's called a net. What's a net? A net is a diagram of the surfaces of a 3-dimensional shape, a solid, that's laid flat into 2 dimensions. So one thing that you would get, like right here, do you guys see a capital T here? Okay, it's not a capital T. It is actually a net for a polyhedron. So when I put it together, what shape did I get? As close as it's going to get without me in the good. What shape am I going to get, guys? Rectangular prism. Wow. But it looked like a T. But that's where they want you to be able to do. They want you to be able to, in your mind, fold it in order to make it a 3-dimensional shape. People are really good at this, or people who do origami. Hello, right? And so make sure you know those. Now here's an example of a silly little net. All right. This is like one of those cute little containers that you can put stuff in for Valentine's Day. Isn't that just precious? But look what it looks like when I lay it flat. If I take that, and it's kind of like taking a box and laying it flat, look at the shape I get. Where are my bases on that net? Are going to be rectangles, triangles, what are they? Yeah, so it has to be the congruent one. So this would be a base, this would be your other base. The other ones are the sides of it, or the lateral surfaces, but that's easily what a shape you can get from that one. And that's just a triangular prism, right? And the way you would name that is you just say, oh, look, a triangular prism. But I don't know how many times people told me that that can't be, so that's a pyramid. When they look at something like that, they go, oh, look, a pyramid. And I'm like, you should have all the faces should be triangles, right? But those type of things you're expected to be able to do. A hint on your homework, if you're really bad at this, the best thing to do is to take a little piece of paper, trace the diagram on the paper, cut it out and fold on the lines. It will fold and it will tell you if it makes a net of something or not. So those of you who are very hands-on, it's kind of a fun homework because you actually have a little more time to do that. But when you name it, you need to name it well. So here's some ideas, like this is the stuff you're going to see that you're expected to know. Like on A, what would you describe that net to make? The cube. And I would go with cube on that one as well because all 6 sides are the same. Now, I could have this drawn differently. And on your homework, you're going to be asked, will these make a cube? And every one of the things you're looking at will have like 6 cubes and stuff. I mean, 6 sides. You have to decide if it folds to make it or not because you can't have any overlaps. You can't have all that type of stuff. So make sure you're able to do those. A fun thing to do is just Google online. Go geometric nets, and you're just going to find tons and tons of diagrams of geometric nets online. Even some programs that will sit there and let you play with it, and it will animate it and stuff for you. Pretty simple. All right, guys, what would you call B? Yeah, it's just going to be a cone. Now, another thing with cones, if you ever see something that looks like this, that's still a cone. A cone is basically formed from a circle. So the curved surface of a cone is basically a circle with just like a piece of pie cut off of it. And then you just point it around, and the center of that circle is going to end up being your vertex point. So that's the way you'd make those. So cones could look like you see right there. It looks almost like a human, you know, simple symbol for a human. Or it could be like a Pac-Man type shape, anything like that that you're working with. All right, what would you call C? Yeah, I would say a triangular pyramid. Because if I was to fold on these lines right here, wouldn't that triangle in the middle end up being the base? And everything else coming up from a vertex? All right, and then what do you get for D? Yeah, the cylinder. Now be careful. There's times where I might be mean and I will actually, you know, draw a cylinder out and I'll make it too small of circles to make it or something. And you'll be like, that won't make one. I'm like, yep, I know. That you're supposed to recognize that. So be very careful when you're working with those. Are you guys with me on that? All right. Another thing that you're going to be expected to know, and this is huge when it comes later into like pre-calculus and some college algebra and algebra 2, is we're going to use a term called a cross section. Now let me explain what a cross section is. A cross section, this is the formal definition. It's the intersection of a 3-dimensional figure and a plane. Basically, think of it like this. I have a figure that's a solid, and I have the plane is a saw, a blade of a saw, right? A big blade of a saw. And when I cut through with that plane, what 2-dimensional shape would I get as a result? So this is kind of like I was explaining to the other class. You know, you have a whole loaf of bread, and then you slice the pieces out, right? It's like, what's the slice? It's the slice is the cross section. It's not the whole loaf. So again, it can't be a 3-dimensional shape. It can only be like a 2-dimensional shape. You with me on that? So, like on this first one right here, it says describe the cross section. You guys are gonna have to describe the cross sections with this. That plane is intersecting at the very tip of that cone. So what's my cross section gonna be? It's a what? It's a point. That's the only intersection I have, right? So it's a point. So in this case, it's just a point. Now, what would happen if I took that plane and I intersected it lower? You'd have a circle. What if I had a plane and it was really skewed when I intersected it? What would my shape be? Careful, because if I hit it as a skew, that's an oval, isn't it? Or AKA fancy math term, an ellipse. Or what if I decide to intersect my plane this way? What would you get? It's not going to be a triangle because the surface I'm intersecting is curved. So that means this is going to be, nope. It's not a semicircle. It's just going to be a parabola. Ah, it's a parabola. Parabola. So when you slice it off of its side, it's a parabola. It makes a U shape. Now, you have some other ones as well that you'd have to know on that. So here's the thing. Is it parallel to the base? It makes a huge difference or not. What you can say. Like here on this next one, we have a pyramid. Guys, what's the two-dimensional shape that you get as a result? Where they intersect? Yeah, you're end up going to get a pentagon. Notice I didn't say it was a regular pentagon. I don't know enough about if it's parallel to the base or not. What about the next one here? What do you guys get? Yep, let's finish it up, guys. So we got a hexagon. What's the last one? Triangle. All right. Now, the last example is a little more fun, though. All right, this is for entertainer. Like, what if I have, now this is an imaginary thing here. I want to cut cheese so I can entertain it and make it look pretty. Now, I don't know of any cheese wedge I know that's an equilateral prism like this, triangular prism, but it's the case. So it looks something like this. How would you cut it to make equilateral triangles? Yeah, parallel to the bases, right? So you cut parallel to bases. Okay, now look at the next one. What if I want to make a rectangle? How would I cut it? Parallel to the faces. You could say parallel to the other faces or perpendicular to my what? Could I cut perpendicular to my bases here? And would I get a rectangle? Yeah, so you could do perpendicular to the bases. Now, little things like that you're expected to understand. Are you guys good? Yeah. All right, go have a good day. I'll see you in community time.